All right, homework 6.6. Let's see here. Solve the log equation, solve the extraneous solution. All right, so on the first one up, we've got this property that says if a log of some base with an argument of a, or let's say x, is equal to a log of the same base with some argument y, then x is y. You'll notice there's just a log on each side. So because of that, we can say that the argument of both logarithms are the same. And then we can shift everything to one side and presumably factor. Let's see if she factors. See, it takes an x and an x to make x squared. Factors of 5 are going to be 5 and 1. I want to be a -4 minus 5 plus 1. Easy peasy lemon squeezy. By using the zero product property, x minus 5 is a 0, or x plus 1 is a 0, which means that x is 5 or x is -1 by adding or subtracting, vice versa. Now, check for extraneous. So for a logarithm with an argument, the argument's bigger than 0. If I plug a -1 in here, I'd have -1 squared minus 4 times the -1. And this is going to return a 5, so this works. If I return a 5 in here, I'm going to have 25 minus 20, which is 5, so they both work. There is no extraneous solution. They're both real. Let's see here. Let's do this 4. Yeah, let's do that 4. It says figure out what log of 1,000 is. Well, I happen to know that 10 cubed is 1,000. So this is 3. 3 minus 2 logs of 3x minus 1 is -3. We're going to subtract that. -2 logs, whose understood base, by the way, is 10, of 3x minus 1 is -6. We'll play the isolation game. Divide out that -2. A log whose understood base of 10, whose argument is 3x minus 1, equals 3. Now we're going to convert to exponential form. We're going to do bay. On the opposite of it, bia. Base is 10, the exponent is 3, and she equals 3x minus 1. 10 cubes 1,000. We're going to add this 1 over here. We're going to have 1,001 equal to 3x, and we're just going to divide by 3 and move on with our life. Will 3 enter that? No. So 1,001 over 3 is your answer. All right, number 5, we are going to have to condense these logarithms. So I'm thinking about a pretty simple property for a logarithm with a and b inside of it. It'd be log a plus log b. So since these are both log base 4s, I'm going to make them a singular log whose base is 4. And inside is the product of x and x minus 6. Still equal to 2. Now I have a base, I have an argument, and I have an exponent. 4 to the 6 must equal, let's see here, x squared minus 6x. Now, what on earth is 4 to the 6? That's a big number. 4 cubed is 64, 256. Lost my place here. 4 cubed is 64, right? So 4 to the 4th is 256. 4 to the 5th is 1,024. So 4 to the 6th is going to be 4,096. So 4,096 equals x squared minus 6x. Let's see here. We're going to shift this over, make it negative, and put a 0 on the left. And then I guess we'll try to factor this thing here. So I need factors of 4,096, add to -6. Give me just a second. I don't want to waste your time while I think about it. I'll be right back. Well, actually, I just realized I made a mistake. Where did that 6 come from? It's not supposed to be a 6. It's a 2. Well, that makes the problem much simpler, because 4 squared is 16. So, now, are there factors of 16 that add to -6? Yes, there are. They're 8 and 2. So 0 equals x minus 8 times x plus 2, because we want to add to that -6. So our zeros are x equals 8 and 2 by zero product property. 2 has an issue Because if you put a 2 here, you'd have 2 minus 6 inside, which is negative 4. So this one is extraneous. There's your extra. All right, solve the exponential equations by rewriting each side so the bases are common. The reason we do that is because of another little theorem. It says if, let's see here, b to the x equals b to the y, then x is y. So when I look at 8 and 32, what I see is I see powers of 2. 8 is 2 cubed, and 32 is 2 to the 5th. Now, I already had an x minus 1 on the left in the exponential space, and I have a 3x minus 2 in the exponential space on the right. So since the bases are the same, I know that 3x minus 3 equals 15x minus 10. You'll notice I did the distributive property there. I'm just going to get my x's on the right, numbers on the left. 15x minus 3x is 12x, and negative 3 plus 10 is 7. Divide out the 12, and my answer is 7/12. Easy peasy lemon squeezy. All right, number 10, solve the exponential equation by converting into a logarithm. Now, obviously, the first thing we're going to do is we're going to isolate the base. Isolate that base. So we're going to add 10. That's going to give us 28. Now we're going to divide out the 2. 28 over 2 is 14. Now, you might be tempted to think that 14 has a power of 7, because some of you just bless you, but it ain't. We're going to do log is bay. We have a base of 7. So we're going to have a log whose base is 7, an argument of 14, and she would equal 3x minus 2. Now, we're going to add 2, divide by 3. We're just going to shift that 2 over. Log base 7, argument 14, add 2 is 3x. And then we divide by 3 and we're done. Now, if you want to know what the answer to this problem is, you need to use change of base. Log base 7 of 14 is the natural log of 14 over the natural log of 7. And then we're going to add 2, and then we're going to put it all over 3. That's how we're going to push buttons in a TI-84. Oh, I don't have much time. I still got to work on a twin. All right. So what did I say I had? I had the natural log of 14. She was sitting pretty over the natural log of 7. We're going to have to add 2 to that. Then we're going to divide it by 3. And there's your answer. 1.1187. Make sure you can get that at home. 1.1187. All right. 13 is marked. You're supposed to solve this by taking the natural log of both sides after isolating the base. You always isolate. Some of y'all ain't figured that out. You need to. So what I did is I subtracted 4 from both sides. And now I'm going to divide out the 3. And now I'm going to use this ln technique, which is a really elegant technique. We just put an ln on both sides. Now, the reason it works so well is because the natural log of e is 1. First off, these exponents become factors, so 4x minus 1 goes out front. Then you have a natural log of e. And of course, since the natural log of e is 1, you just have this. 4x minus 1 is the natural log of 4. 2 moves and she's done. You're going to add 1, and you're going to divide by 4. So x is the natural log of 4, add 1, and then all sitting pretty over 4. And there's your answer. If you want to know what it is, push buttons in a TI-84. 15, I'll just let y'all ask because you will. 16, I ain't doing it either. Let's see, let's do 18 and then be done. Completely expand this logarithm. So I've got some text over here that tells you how to do this. If a log is positive, the argument belongs in the numerator. If a log is negative, the argument belongs in the denominator. We're just going to do that backwards. Every single thing that's in the numerator is going to be a positive log. Even this guy, even though he's in the wrong spot, it'll take care of itself. All right, the only negative thing is down in the denominator, at least for now. Now, this is something you can answer. This says, what power of 5 creates 125? And that's a 3, by the way. Remember that exponents go to the front of the bus. That was taught before the snow break. I'm sure you remember that. Goes to the front of the bus, so minus 2 log base 5s of y. And then minus log base 5 of, sorry, not minus 5, that. I forgot to move the 4. Minus 4 log base 5s of z. Oh, I can tell it's going to be a Monday already. Well, there you go. There's some of your homework. You're welcome.